This movie is about some additional aspects of UML that you might use or find in class diagrams. We've already looked at the basic notation that you're most likely to need, but this movie includes some other notation that you may need less often. I'll explain interfaces in UML, briefly contrast them with abstract classes, and then look at enumerations. In practical terms, an interface defines a set of operation signatures that any classes that realize or implement that interface must provide methods for. One of the reasons for defining interfaces is that some programming languages don't support multiple inheritance. So it's possible for classes to inherit some functionality from a superclass, but also have other functionality defined for them in an interface. The difference is that they can inherit default behavior from a superclass, but must implement methods for the operations in an interface. However, the use of interfaces in programming languages varies and changes over time. For example, Java 8 now allows interfaces to include default implementations of operations. Interfaces are also part of a model of programming that clearly separates the signature that classes or components expose to the outside world from the implementation. This is known as information hiding. People also speak of interfaces as contracts. Any class that realizes an interface is obliged to provide implementations of the operations whose signatures are defined in that interface. So timed event and triggered event must both implement activate, though each can do it in a different way. The name of the interface has the stereotype interface above it. Classes in an inheritance hierarchy can also be declared to be abstract. They can have attributes and operations, and the operations can have default implementations that will be inherited by subclasses that don't redefine them. However, being abstract means that they will never be instantiated as objects. So in our system, if we make device abstract, there will never be an instance of device, only of one of its subclasses. The class name is shown in italics, or it can have the tag abstract in braces under its name. Enumerations allow us to define data types that represent lists of permitted values. Within UML itself, enumerations are used for lists of permitted values like the different kinds of visibility, which are defined in the specification as visibility kind, an enumeration with the 4 values public, private, protected, and package. An enumeration doesn't have attributes or operations like other classes, but the values set as its attributes are shown as a list of values in a compartment in the enumeration. The name of the enumeration has the stereotype enumeration above it. Now let's look at how you would add these elements of notation to your class diagrams. Here's the domain diagram from our earlier work. We'll add a new diagram to hold this aspect of the model. So I'll first create a new diagram in the domain package called events. I right-click on the package and select Add a Diagram. This will be a UML structural diagram and a class diagram. I need to give it a name other than domain, so I change the name to Events. I click OK. It's opened the diagram for me. Before I add anything new, I need to drag timed event and triggered event from the project browser into my model. I select Link. Now I'm going to add a new interface. Interface is in the toolbox. It looks like a lollipop on a stick because that notation can be used in component diagrams, which we'll see in another movie. I select Interface and then I click on the diagram. I'll call this interface Activatable. If you know you're modeling for development in a Microsoft environment, say using C#, you may want to follow the convention of naming it something beginning with a capital I, like iActivate. Different languages have different conventions. You can see the stereotype in the name compartment above the name of the interface. I'm going to add the operation signature for activate into the interface before I connect the classes to it. So I right-click, select Features and Properties and Operations. I add the operation activate with no parameters and no return type. Now the two classes need to realize this interface. Realize is the UML term. It's equivalent to implement in Java or C#. To do this, I need to add a realize relationship, which I can do with the quick linker or by selecting it from the toolbox. In this case, I'll use the quick linker from timed event, and I select realization. When I make this connection, Enterprise Architect asks me whether I want timed events to implement the operation activate in Activatable. I select it, as I do. You'll see that it's added activate to the operations of timed event. I'll do the same for triggered event. To contrast this with abstract classes, I'm just going to make an existing class in the model abstract. I'll do this to device, which is shown in an inheritance hierarchy in the home network diagram. So I'll open that diagram. Note that at the moment, device's name is in normal type. Select device, double-click on it to open its properties, and go to the details page in the pane at the right. You can see there's a checkbox for abstract. I check that and close the dialog. The name of device in the class in the diagram is now in italics. Let's go back to the events diagram. Now I'm going to add the enumeration for device action. The timed event class has an attribute for action of the type device action, but we haven't defined it yet. Enumeration is in the toolbox, so I click on it and add to the diagram. I'm going to call this device action. You can see again that it's stereotyped as an enumeration in the compartment above the name. I'm going to add a list of values which I add as though they're attributes. So I open up the properties page for attributes and I'll add the following values: open, close, on, off, and sound alarm. You can see the values listed in the attribute compartment of the enumeration. I'll also add the attribute to the triggered event class, just so that it's consistent. You can see the enumeration listed here beneath all the classes and interfaces. So, in this movie, we've learned about interfaces and added one to the model. We've changed device into an abstract class, which means it won't be instantiated, and we've added an enumeration to the model.